Okay, so there was your answer. Now here was my question to you. I asked a whole bunch of you, and I never really got a super confident answer. Okay. What we did was, if I pedal back to here, okay, if I write this out without sort of simplifying and just keep it in general terms, what we've really done is this. You got one integral from a to b, and then you square each function independently. So you got y squared, then you've got y, the other y squared, and then you do the whole lot with respect to x. Okay, that's what we did. Okay. But my question was, if we come back to this, which is saying it's about an area, and that area is rotated, okay, why is it that we don't compute the volume the same way you do an area? If you did the area, right, you'd go pi, sorry, not pi, this is an area. You'd go a to b of square root of x, that's the bigger one, 1 on the square root of x, then you do that. Okay. Now if I apply my normal volume equation, volume formula, to that, you stick a pi out the front and you square it. Okay? Which is not what you did. And it would give you quite a radically different answer. Okay? My question is, number one, why does it give you a different answer? Number two, why is that answer wrong? Maybe number three, what answer is it giving you? Because it's giving you something meaningful, it's just not that. Okay, all right, let's go to number one. Why is it wrong? Why is it wait, was that my first question? Yeah, why is it wrong? Well, you say, okay, squaring the whole thing, but why not square the whole thing? Like, that's what a volume does. You square the whole thing, whatever y is. In this case, it just had to be very simple. But if it had more stuff in it, you'd square the whole lot. So why is squaring the whole lot bad here? Let's just give it a go. Let's see what happens. Okay. So you'll get pi 1 to 4. Okay. What do you get in here? Because we can deal with this. A squared plus 2ab plus b squared, right? So that was x minus 2 plus 1 on x. Okay, now just compare that to what we actually integrated, right? And you're like, that's totally off. That's completely different. Okay? Why is it completely different?
Because the minus.
This is difference of squares, isn't it? Okay? This is the square of a difference. Right? It's the square of a difference. And they're not the same thing. Okay? Now how can you convince yourself that it's this one and it's not that one? Think carefully. This is at the point at which no one could give you a good answer. Okay? And it was probably because you didn't have your volume drawn. That's a big clue. How can you look at this thing and tell me, of course this one? What were you smoking when you wrote that, right? Look at it with me. The reason I come back to this is because you can see from the diagram. It's one volume minus a whole different volume. The volumes, I'm thinking of them completely independently. Hear that? Completely independently. They only come together because they happen to have the same constant coefficient and the same upper and lower bounds. What you do here is no longer treating them as independent. You're mixing them together and then you're taking a volume. That's confused. So number one, it's wrong. Number two, the reason it's wrong is because the two volumes are actually totally different guys. Okay, that's why you compute them separately. We just so happen to notice that algebraically you can do them together. All right, bonus question. What volume are we working out? What is that volume? Because you know what? It's almost on my diagram. It's almost there. Now remember, I gave you some dodgy arguments before for why this was right. I said, look, this is the area that I was asked to do. And this is what happens when you turn an area into a volume. Okay? So I am actually working out a legit volume. What volume is it? It's the volume defined by this area, but what's the difference? Now, of course, I could say it's a different graph. Sure, it's a different graph. But then again, so is this. This is also a different graph. Okay? It just so happens that that graph is exactly the same one as the ones that I want. Okay? But this one is not. What would it look like? The difference here is, this will give you the area, sure enough. But it will only give you the area. It will only give you, I shaded it in black. It will only give you this thing. Okay? Now what this has, which this lacks, is that, see this gap here? Where did this gap come from? It came from considering the two volumes independently. Okay? But when you stop thinking about them independently, all you have is that area. That area, what's it look like? This distance here, does anyone know what it is? That distance there? It's a half, okay? So that distance should come down to here, so it'd be something like this. That'd be, now that was 1 before, so it actually should only come up to about a half. That should be shallower, okay? Then that comes up to, well this came up to 2 before, didn't it? So this would come up to about 0, a half, 1, a half. Something like that. There's my area. There's the area I calculated there. And now I do what this does, which is rotate the thing, like so. Oops, it's upside down. Here we go. And there's a cone in the middle. Ta-da. That's the area, sorry, that's the volume we just worked out, because it's that area rotated around that axis. Okay? But you lose that data when you forget about thinking about them independently. Okay? So that's why it gives you the wrong answer. It gives you the right answer to a different question. Does this make sense? Now, you need to be able to reason that yourself. Like I said, this is pretty easy numbers. The diagram's not too bad either. Okay? I hope we've rammed home enough, right, that when you get something that is lifted off the axis, you'll end up with this hollow volume. How do you evaluate it? You consider the two volumes completely separately. 1, 2. Okay? Which, as a side note, is why it's dangerous to just memorize formulas like that. You just memorize that, you're in trouble. Because you're like, oh, wait, did I square them first? Or did I take the difference and then square? Okay? The formula kind of obscures it, right? That's why it's kind of like, well, this is not a shortcut, it takes longer to write, but the reasoning is clearer. Just makes sense?